Hello, good morning. I assume you cannot hear me, right?
I
Is
can
okay?
clearly hear you.
Oh, cool. How did that happen? Okay, good. Good morning and good afternoon in China. So,
Good day, everybody. Marius, ready to go?
Yes. Okay, so welcome to the QE Tools Team workshop. And today I'm going to present um, new performance improvements in OpenQA, or rather actually the OS AutoInst backend. And I hope you can see my shared screen, which currently only shows the
Not yet.
browser window. Okay, good. So I haven't shared that yet. Right, that was just for the OBS recording. So
Now we are good. Yep.
here you go. And yeah, so that is this topic which we announced in the workshop topics. And it's mainly about the functions wait screen change and wait still screen, as you can see here. And there are also two tickets linked that are about these changes. And as you can see, only one of them is crossed out. So what I'm telling you here is actually only partially merged and ready in production right now. So, but I will tell you, of course, which parts are already in production and which not. Um, but let's start with the motivation. The motivation was actually, at least when I got involved into this, the ticket, test fails in Chromium due to lost characters when typing in address bar. And lost characters while typing is unfortunately a problem we see not only in Chromium, and therefore we actually had a very easy solution already in place, which was to use simply um, wait screen change as a parameter of enter command. Enter command is basically type string.
Would you
So
please zoom in by 2 steps?
yes,
Yeah, thank you. That makes it a bit more.
yeah, I'm not really going into details of that ticket anyways, but yeah,
Sure.
that ticket is also already a little bit older. I think there's also nothing interesting to see. Likely everybody has seen that characters were missing while typing. Hopefully not that often, but some applications like Chromium can be problematic. For instance, in Chromium, I assume because it does already many things while you're typing to provide you a list of suggestions. And yeah, that ticket could have already been resolved actually, because I'm not quite sure what the assignee, which is Chris here, is waiting for. He's on vacation. Um, so it was basically resolved by adding wait screen change to the type string or enter command invocation, but it has, of course, a performance impact. So if we wait for screen changes and also use wait still screen, that and that just needs some time to process, and actually is now, even after the performance improvements, still a slow thing. So you really should keep that in mind. I've tested it for type string. I tested my performance improvements, um, but I also tested how it is if you use type string just normally. And of course, if you add wait still screen, it's still slower by, I think, factor 3. Of course, it depends on the amount of typing you actually do. So keep in mind, despite all the performance improvements, it's still a slow thing to wait for screen changes or wait for a still screen while typing. It's really just to stabilize tests if needed. But if it's needed, then likely the stable test is preferred over a non-stable test, even though it's slower. So the first improvement was to wait screen change. And as you can see, that ticket has already been marked as resolved. And that part is already merged and deployed on OSD and O3. So basically that call is now just faster. And that also affects if you use the wait screen parameter of type string or enter command. And in particular, we now have also the no wait option here, similar to other commands which also have the no wait option. And that makes it even faster. So you can use no wait if you expect that the screen would change almost immediately. That's of course the use case when typing. So type string and enter command will use the no wait
That
parameter
means
internally.
after every character. While we type one character, and of course we normally assume that that character more or less by human standards immediately, and then we can continue typing, right?
Yes. So basically, a type string is then just calling wait screen change in a loop, and that loop is basically typing character by character and waiting that was waiting for a screen change before entering the next loop iteration. I will go into a few details after that, but before I will just go to the next improvement, and you can see that ticket is still in feedback. So these changes now have not been merged yet, and it is about wait still screen, even though the title doesn't really mention it. It's mainly to remove, I mean, the motivation here was again to remove a sleep. But in the end, I basically removed the whole loop. You can see that later. That also resulted in a performance improvement. And yeah, that is basically the same as before, just for wait still screen. You can also use wait still screen when typing, and it already has a no wait parameter, but now it's more efficient. And I think I will also just show you the code. Yeah, right, because in the code and the pull request, actually, I also mentioned some performance measurements. Okay, so what could be improved? Let's start with wait screen change because that's definitely the simpler one of those two functions. So that is basically code of OS AutoInst. And I just show it to you because maybe you are interested in how things work generally, but maybe if you have troubles understanding that, I should maybe go into the documentation before, just so you know roughly what's actually happening and where these pieces of code are actually executed. So when you launch ISO to video, that process will actually spawn further processes. You can observe all what's documented here. Actually, also if you just use some task manager and show the tree while a job is running, then usually also the backend is running. The backend is basically what processes the VNC data, does the image comparisons and so on, and that is running in a continuous loop. And that's what we see here in base class PM, those changes. Then we have more processes spawned by the backend, but that's not really important right now here. Then we have auto test, and that one is also important here because that's where your test code runs. And the other things are not important right now. And the call to wait screen change, maybe we should start there. That's the function wait screen change. And I show you maybe, that's already.
Also zoom in on the GitHub page.
Yes, I just noticed I made a mistake that was annoyingly wrongfully merged in a different pull request.
Okay.
Good to know.
Yeah, at least parts of it have been wrongfully merged in a wrong pull request. Nobody who reviewed it noticed that an unrelated pull request contains changes.
Glad that I was in vacation.
Yes, you were on vacation, Oliver. You were not at fault. Yeah, so that were the changes, and now I can also zoom in a little bit. So that's the auto test process, basically. I mean, code we see here runs there, and that's, you can see it, the start of the wait screen change function. And it contained a loop, and that loop was basically polling the backend for screen changes. So all of the logic was actually handled within the auto test process, and it repeatedly calls the backend to check the similarity of a previously taken reference to the current screenshot. And well, it's actually quite simple. If the similarity is big enough, less enough, that's wait screen change. If the similarity is less enough, then it says, okay, we saw a screen change. And if not, that's unfortunately the annoying part, then it needs to sleep a while to not overload the backend, and then just poll the backend again. Of course, such a loop isn't very efficient, especially considering that the backend already contains a loop, which is much more intelligent when it comes to waiting. And so we basically have here a loop that is polling for the outcome of another loop. And therefore my new code changes that. It basically just calls the backend for a screen change, and that call will now simply block as long as it takes for the screen to change, or of course until a timeout occurs. That's the else part. So now the code of that function looks rather simple. It's just one call to the backend, then a little bit of logging and returning a certain return value. Yeah, so now that is quite simple. Of course, it means now the backend needs to do more. And therefore, I'm scrolling to the top. So let's have a look at baseclass.pm. The backend, as I mentioned before, has this big loop processing VNC data and a lot of things. So the loop is the function doCapture. I think it's also called the capture loop. And as you can see, it's basically an endless loop. So as long as the backend is running, it will definitely also run that loop. And it has some parameters and handling for timeouts, as you can see here. It's not very important to go into details, but let's just say the backend is a bit more clever than just putting a sleep at the end of the loop. It really tries to figure out how much it should wait, um, how much it can wait actually to be responsive enough um, to have a certain VNC polling interval. VNC is actually a protocol where the client is polling how often the client thinks it needs updates. And of course, it would also resume immediately if it has anything to read on with certain sockets it's reading on. And now I simply extended that loop to check, okay, do we currently wait for screen changes? That's basically that new function here. And well, that function simply checks whether we check currently or wait currently for screen changes. And if we do, we basically do the similar logic as we saw earlier in the test code. However, in the test code, we saw a loop. Now here we don't see a loop because that whole function is already executed within the loop. And we call similarity to reference. Of course, now we don't need query ISO to video to tell the backend to do that because now we are within the context of the backend. And then we also do some similar check to determine whether we actually had a screen change. Sorry. Then we
A
need
short
to,
question for this function.
yes.
Of course, we are within the process of one cycle of the event loop. This function it must return within a reasonable small time, right? So
Yes.
must not block on something which takes a second or so.
Yes, of course. So that function shouldn't be very expensive to call. Of course, it does a few things like comparing images, but that's not that expensive. And it also, of course, always returns early in case we are not actually waiting for a screen change. So in most cases, that function does actually nothing. Yeah, and of course, we also handle the timeout, and we can make use of things we have anyways here, like we know already the time from the context of the whole loop. And here we have the logic similarly to before. So if nothing has changed, but also the timeout hasn't been executed, we just return. Of course, if that's not the case, then we actually need to send back something to the test process, and we need to remove that we actually wait for screen changes. And we will basically send back the results as we determined them before using the normal IPC code we had in before. And that wait screen change that's just populated by this function here. It's basically the function wait screen change. That's the function executed by autotest in the test code we saw earlier, and then it is returning postponed equals 1 instead of just what that call is supposed to do, because here, in contrast to other commands, we don't immediately send back the response within the direct call. We postpone that and leave it to the capture loop. That's actually a new mechanism I have introduced, because before it was actually always immediately returning from these functions. Yeah, that's also this change, simply to handle the postponing. And the autotest process will simply block anyways already until it gets a response. So on that end, we are actually already covered. So that is basically the query ISO to video function I was talking about, that always blocks until the backend actually responds something. We already use that mechanism in the developer mode. When it's paused, then we basically just don't respond until the test is resumed again. Okay, so that was it code-wise. Of course, everything has tests. And then I also have the second change for actually supporting no wait in wait screen change. That was then a simple change in the backend code.
So the first one was a performance improvement, which we can benefit from in general, right?
Yes, right. The first was a general performance improvement. We basically just moved out the polyg loop from the backend,
From the
the
API,
autotest
move that
process
into
to the
the
backend.
backend.
And here we tweak it a little bit. So now the function wait screen change gains support for the no wait parameter. That, of course, means we need to do VNC updates more often while we are waiting. That's this part here. And I don't think I should go now into any details here, unless you want me to. I just want to point out I still have that pull request open. That's basically the very same thing, just for wait still screen. So it already uses the introduced code, the previously introduced code in the base class .pm, and adds a similar function to check whether we have currently whether we are currently waiting for a still screen. And that code is now a bit more involved, because still screen doesn't need to only check whether the screen hasn't changed in comparison to the reference. It also needs to check whether it's still long enough. We can specify how long it should be still, and it would wait until it's really still so long without interruption, or basically a change in between. Yeah, but as you can see, the overall idea is very much the same. And unfortunately, it hasn't been merged yet. Yeah, a little bit of a disclaimer: if you notice any wait still screen related problems and that has been merged, maybe it's actually related to that pull request. Of course, I've already tested it locally with many jobs I've cloned from O3. And of course, it also has unit tests.
One
Yeah,
question here. What can you remind me? Where do you a paradigm of wait still screen?
sorry, I couldn't really understand the question. Where do I what of wait still
If you
screen?
can describe a use case or a paradigm of wait still screen, how do you use it?
I
Is
think
still screen means when you wait the screen to be, you expect the screen to be the same still.
yes, I suppose you use that, for instance, after you invoke a command on the terminal or click somewhere and you expect that something is going to be animated or something on the screen will happen, and if it's still, you know, it should have been done. So, for instance, if you open a pop-up window, but you know there's some fancy animation before you can actually do anything, you would use it. Maybe it can be useful while typing. I'm not quite sure when that is used. So in the Chromium case, we, or actually better Chris, who implemented that, settled for wait screen change.
Yeah,
But
we can come into general suggestions afterwards. Janis, it's a very important question.
yeah, I'm actually also wondering when both of these functions are better or what the use cases are. I'm of course not a test developer myself. I basically just made the functions faster and they are really kind of opposite functions. So maybe that is actually worth discussing afterwards. Before that, wait, where do I have it? I thought I had a lengthy comment here saying how much faster it is. Apparently not. Mm, what pull request was that? Was my comment lost? Strange. Yeah, but I can tell you, um, I really did some testing using OS AutoInst's own full stack test, and that function is now really significantly faster. Using it is still slower than not using it while typing, but when you enable it for typing, then, well, before it was really ridiculously slow, like I think 20 times slower than not using it, and now it's only 3 times slower. So that's definitely a plus. One caveat, of course, now when that pull request will be merged, we will look at the screen more often, especially if you use the no wait parameter, but also in general because we got rid of the sleep 0.5 and all the communication overhead. So in general, we are able to be a bit faster when it comes to looking at the screen, which of course means wait still screen will be able to see smaller changes and also take them into account. So maybe some wait still screen call that was successful before because the change was happening very fast and was ignored will now actually fail. That's maybe a problem. I haven't seen it in reality, well, at least not anymore on my final version of the changes, only on a version that was a little bit broken before. But that's why I was was thinking about that in the first place. Yeah, so that was the main presentation. Maybe one last point. There's also the function send key, and here we have not yet implemented any support for no wait. So send key shouldn't be much faster, but there's um, at least a ticket to add the no wait option here.
In send key until needle match.
Yes,
Might
send key
also
until
be special. I don't know the implementation right now. It might also be a candidate where we better move something into the event loop handling itself to
maybe.
support use cases like this one. So here what we can see is actually test code, which is perfectly valid test code. And this might be a candidate where this test code could be simplified by use one of the existing test API functions, but with the according no wait parameter.
Yes, it will likely just be an extension to send key. So we can remove the loop similarly to other functions.
Okay, maybe we can try to summarize a bit. You don't mind? I would try, and then obviously you
Yes,
can
that's
correct
a
me.
good idea.
Okay, so we have the no wait option on various test API functions. We already had that initially, insert screen and check screen. And by default, when we call anything which is related to screen checks, then there is a certain waiting period, something like half a second. And we do that to, let's assume you're conducting an installation of SUSE, and you call a search screen on installation done screen, right? Then we expect that this will take some minutes, or even in centers, it might take an hour or something. So there we would like to make efficient use of CPU resources, so we don't check the screen as quickly as potentially possible, but only every half a second, right? And this is why we have the no wait option to say explicitly people can select when it's needed to very quickly check when we expect that it won't take long for a screen. The most important example you mentioned is typing individual characters of a string, or let's say in the address bar of a browser, you would type hello, and then you would type H, the first character, wait for H to appear, and then continue with it. In this case, you optimized when using no wait, which also happens implicitly because the function in that example which is used is enter command, which uses type string. Type string is supporting the no wait parameter as well as wait screen change as a parameter. So both of them combined are now more efficient, right?
Yes. By the way, I have actually already had a look at the Chromium test module, and now you can see it's taking 2 minutes and 16 seconds. It's always now around that time, and before it was similar, just that a 3 was here in the minutes. So I think we saved about a minute due to the optimizations. Yeah, so that's the annoying Chromium.
So that's a significant improvement that we have
I think,
in this case.
yeah.
Yeah.
And by the way, the call itself, that's basically just enter command and wait screen change. So the wait screen change has been introduced to avoid losing characters, and then that is now a bit more efficient.
Right. Okay. And then we have on the test API level, we have different functions. We have check screen, assert screen, as well as third script run, enter command, type string, which are, I would say, the best option. In particular, assert screen is the best option to start with because it's efficient. It waits for that screen, and if the screen appears, then it returns and continues the test execution. If a test writer, if one cannot use that, then wait screen change is the next best option. It's only the next best option because we are not telling OpenK tests what to wait for specifically. So it will return from any screen change. Some people assume that it's easier to use because you don't need to create a needle for that. And yes, that's true. But you also have that caveat of then you don't specify in particular what you're waiting for. So the synchronization often happens after that. And then combination of, let's say, wait screen change and afterwards an assert screen doesn't really save time. At least one more additional. And I would say the least best option would be wait still screen. So it's the rather a choice that should be avoided because there, by definition, there's always some waiting time that you need to pass anyway. I mean, you need to wait a little bit of time to say, oh, actually, during the past time that I waited, let's say a second or 2 seconds, and this actually can be specified. I think the default is even 7 seconds. Then the test can decide like, okay, the screen didn't change, so now let's continue. So at best, that should be avoided, and assert screen. Of course, wait still screen is still better expressing or what the test is expected to do instead of a plain sleep call. Yeah, because a plain sleep call is used as a very bad instrument trying to stabilize tests when the exact synchronization needs are not clear, which means that definitely the test wastes time and it's not ensured that the desired output is actually present before we continue. Question is, can I specify how much the screen needs to change so that the wait still screen is satisfied? Marius, can you comment on that?
Yes, I think you can. Definitely if you call wait still screen manually. Let's just have.
Maybe you could reference the test API document.
Okay, I would have just looked into test API. Yeah, okay, I'm more a developer here, so I look just at the source. It must be sub wait still screen. And what do we have here? Still time is the parameter. And of course, here you can just specify it as a named parameter. Maybe
that's the time, and then we have similarity level, which is
the similarity level was what I was asking for.
Yes.
Yeah, okay.
Thank you.
The similarity level is basically the same on both, on wait still screen and wait screen change. Of course, that only the condition in which it is used is flipped. Yeah, so higher similarity level means there are less differences. Yeah. And if you use, for instance, type string, you can, as we mentioned before, specify these parameters like wait still screen 1 or wait screen change 1, and then you can also specify things like similarity level, that would be for wait still screen, or the similarity level for the screen change. I am not sure whether you can at that level still specify the time to wait, because that function might try to do something clever internally. Where is that initialized?
Well, we have a wait timeout. The next line after that.
Wait still is actually initialized by wait still screen, which you can not only set to just 0 and 1, you can actually pass the time to wait as value to the named wait still screen parameter. Yeah, I think that makes sense. Okay, so I think that's so much for parameter passing.
Yeah, thank you very much.
Maybe I have a look in the chat. Yeah, a question.
Yeah,
Can
that
I
was the
specify?
question.
Yeah, okay, that was it already.
Yeah. Janis.
Yes, please speak.
Yeah, so the initial problem was the type string that losing characters, right?
Yes.
Okay, what's the correlation with the if the TypeScript string can take a number to define the speed of typing? If the OpenQA was performing poorly, why will the slow typing work or not? Why?
I suppose you could, of course, also just enable the workaround to type slowly, but that's then even slower, because you really definitely wait for a certain amount of time unconditionally before typing the next character. But here we have at least the chance to be faster by saying, okay, the screen has changed, next character. The screen has changed, next character. And hopefully the waiting for the screen change is faster than just a sleep of, let's say, 1 second you put in there.
Yeah, that's actually where the improvement comes from. The test module previously ran for 3.5 minutes because it was using that to type, let's say, at a medium speed, and still problems were appearing. So what we tried out is type even slower, and then it would take something like up to 10 minutes for the complete module to execute. And then we said, like, okay, obviously that's too long. So what Marius has shown here, that we could go down to 2 minutes, is because of using that intelligent approach, which is actively checking the screen. And you might think that, well, that's costly, but in the end, it's way better and more efficient.
Yes, it's not that costly, considering that we actually need to call the VNC server anyways for updates. So that loop we run anyways. And we anyways enqueue a new screenshot. So yeah, there is actually a lot already going on, and we just insert a small check in the middle.
Okay, thanks.
Yeah, of course, it's a bit annoying that Chromium, while it is computing anything, whatever it tries in the background, that it's then possibly losing characters. I mean, that could actually also be a usability issue. But yeah, I think that is the best we can do to make our testing work.
Okay. Marius, so do you have more general recommendations of what that now means for maybe other cases of code?
Actually, I'm not quite sure. I mean, I don't write test code so often, and I'm not sure where it's actually already used. I mean, that kind of workaround we've just discussed, or where something would be needed like that. Hopefully, it's not needed in so many places, because it, like I said, sounds also a little bit like a usability issue in this actual software we are testing. But maybe you can share your experience.
Well, the Chromium test module is now a good example of how well, well, for the beginning, there can be different sources why in tests suddenly characters are not showing up when clearly they should have been typed. And you showed one example with Chromium where we assume that the application has dynamic handling of the input while typing, and normally when humans type in the address bar, then they are already automatically reacting to anything showing up on the screen, like a pop-up when suggestions unfold after you type certain characters. And also we must keep in mind that normally the applications nowadays which run an application like Chromium are much more powerful than the minimum requirements VM that we use in many cases here for OpenGators. And the third thing is that if there is unstable handling of the characters already within the application itself, I mean, not problem of OK or the virtual machine, but if this is really how the system behaves on every computer, then humans likely won't even consciously understand that, but just see like, okay, character isn't there, so I will type it or maybe type it again. This also happened in other cases. So here, I think it's really the right approach to do what humans do, which would be to say, I'm typing and then I'm seeing while I'm typing that a character is appearing and that the cursor shows up and I'm ready to type the next character. Sometimes also people type a bit faster, but more or less one would realize like that. So if there are other applications which behave the same, and I'm thinking of maybe LibreOffice could be a candidate which might still be suffering from instabilities, which could benefit from that approach as well. So people maintaining that module could apply the same mechanism. But there can also be other cases, so it's not a silver bullet. So in other cases, let's say there's a console, a text terminal, and you are realizing that you're losing characters there. In many cases, that can be because of whatever has happened in the test, in the history of it. Like for testing purposes, you installed 10 different services, and maybe they're all still running in the background clogging up I/O and memory, and then the system is really just bogged down and cannot react to additional input. Then the solution, I would say that the best solution would be to handle that situation by, making sure that the test can respond to new input rather than typing super slow or with waiting.
Can I interrupt again? I just not sure want to make it clear. When you call wait, screen change, type screen, and password, for example, right?
Yep.
In the high level, you expect wait a screen change after the password change. But now, what I understand is like it wait screen change does it check for each character, right?
There's a wait screen option on type string, and there is another dedicated function called wait screen change. So you mentioned wait type password. Marius, you're showing it on the screen in the last line, which you can see shows the syntax. So type password has the mandatory password string, and it has the option for wait screen. So if you enable wait screen change here, that means that it's handled within that function. And the number can be used to tweak for how many how the weighting is handled within on which blocks of characters.
Yes, so wait is also here apparently not a 1 or 0. The number is actually used here to define the block size, basically how big the pieces the string will be split into will be. And after each of those blocks, or actually rather before, it will wait for a screen change.
Like 3 characters in a row, and then you wait for change and another block. And if one would wrap type password with wait screen change on the outside, like wait screen change and then curly braces type password, which means the 2 test API functions on the high level, then it would mean that the wait screen change happens after type password is returning.
Yes, by the way, wait screen change takes some code to be executed as first argument, as you can see also here. That is because wait screen change needs to set the reference screenshot before the code specified here, then runs the code, and then does the checking. Because otherwise we would have a race condition where you would already maybe do something like, I don't know, whatever you like to do, and then just invoke wait screen change, and then the reference image wait screen change can take would maybe already be influenced by the command you've been executing.
Yeah, exactly.
Yeah.
This was the next question about the race condition. Like, where is the reference defined in here? Where do you pass the reference?
You don't pass any reference. So the workflow is as follows. You call wait screen change and you say, okay, that is a piece of code I'd like to execute, and that piece of code is supposed to cause the screen change. But wait screen change will not immediately execute that code. I mean, that you could do yourself. Wait screen change will first set the current screen as it is as a reference, and then execute your code, and then checks the current screen again continuously against the previously taken reference to decide whether a screen change happened.
And the race condition is happening when exactly in this point?
So in that flow, there's no race condition. That's also why it's designed that way. I just mentioned there would be a race condition if you would not specify the code causing the screen change here, but would simply execute it before calling wait screen change, because then wait screen change can not really race free take the first reference. It would maybe already take the reference at the point the screen has already changed by the command.
Okay, cool. Now,
Okay,
Of
cool.
course.
So with that, we should come to an end.
Right.
Yep. So as you see, you managed to engage us for the complete hour. So thank you very much, Marius, for that interesting walkthrough and also sharing best practices. So as we still have changes for these open, expect that well, there will be a further improvement, hopefully no regressions, but if there are, then please. So with that, thank you for attending and see you again next time.
Yes. See you.